Hello and welcome to Chord Conjectures. Today we're going to look at some properties that are true if two chords are congruent. If these two chords are the same length, then three things will always be true. First of all, the central angles that intercept them are congruent. So if we find the center, if we were to draw the angles here, this central angle must be equal to this central angle. Doesn't really look like it in my picture, but they are. The second thing is that their intercepted arcs are congruent. So remember, central angles, whatever this degree is, if that's 100 degrees, then this arc is 100 degrees. So if these two angles are congruent, then these arcs are also congruent. And the third thing is that if these two chords are the same length, then they are the same distance from the center, equidistant from the center. So if I was to draw a perpendicular line here, that length, whatever that red mark is, would be the same as this distance perpendicular. So those would be the same distance away from the center. Those things are true if two chords of a circle are congruent. Also, just so you know, if a radius or diameter is perpendicular to a chord, then it bisects the chord. So that means if we have this radius here and it's perpendicular, it cuts this chord in half. This one will cut this chord in half. It doesn't cut this in half, it cuts this in half. So this side equals this side. We can use this for the examples. First one says that if OH is perpendicular to AT, so OH is perpendicular to AT. We just talked about that. If that's perpendicular, that bisects this chord and cuts that in half. Also, they tell us that OT is 10 and OM is 8. Find AT. Well, I'm thinking right here we have a triangle. We can do Pythagorean theorem. 100 is 10 squared minus 8 squared. Well, 100 minus 64, that's 8 squared, is 36. If we take the square root of that, we get 6. So this little part of this triangle is 6. And since we know it splits it in half, the whole thing must be 12. AT must be 12. The second example says in this circle, MN is congruent to PQ. So this is congruent to this. Aha! So then all three of those things about chords must be true. They must be the same distance away from the center. So this is better equal this. If OT is 3x and OS is x plus 16,
Corey, please report.
what's the value of x? So that means we got to set this up that this 3x will equal the x plus 16. And subtract, divide, x must be 8. The third example is here. They give us a circle where they tell us that OT and OS are both 15. So this is 15 and this is 15. Wait a second, that means these chords are both the same distance away from the center? That tells us this chord must be congruent to that chord. So MN equals PQ, and they tell us these things, here's MN, and here's PQ. They must be equal because they're the same distance away from the center. So then if I subtract, and if I add here, and divide, I get x is 7. Now if I plug that back in, that would give me 7 times 7, that's 49, plus 13. So this is 62. So this whole chord here is 62, and this whole chord here is 62. Now the question asks us to find the length of a radius. We don't even have a radius here on the board, so I need to draw one. How about if I draw one right here? Because I have a triangle now where I know this side is 15, this side, we got perpendicular, that must bisect it. If the whole thing is 62, then half of it must be 31. That gives me one side and the other side, and I could do Pythagorean theorem to find the third side. If you do a squared plus b squared equals c squared, it ends up being 34.4 is that hypotenuse right there. Okay? And to end this, we have a couple relationships we want to look at. If segment CD is congruent to segment DE, then arc CD must be congruent to what? Well, it has to be congruent to arc DE. So we'll write DE and we'll put an arc over it. The next one says if arc CD, that's this, is congruent to arc DE, then triangle PCD, this triangle, would have to be congruent to what? Well, if those two arcs are the same, then that would mean these two segments are equal. And I'm looking at these triangles, this is a radius and this is a radius, so those would have to be equal. And this would have to be equal to itself by the reflexive property. That would tell me that the triangle up here is congruent to the triangle down here. So we could say triangle PCD is congruent to triangle PED. The next one says if DP is perpendicular to AB. So let's draw that in here. DP and here's AB. If that's perpendicular, then arc AD would have to equal arc what? Well, if that's 90, this is 90, so that would have to equal this. They would both have to be 90. So that is arc BD. The next one says if arc AE is equal to arc BC, whoop, then segment AE, do that in red, this segment has to equal which segment? And I would say right here, BC. If AB is perpendicular to CF, AB perpendicular to CF, then we know it bisects it, right? We talked about that. The diameter is perpendicular, so it bisects it. So FG, this half, is equal to GC, this half. And the last one, if AE, I'll go ahead and erase here. If AE, the arc, is equal to BC, this arc, then AC, this part up here, well, if these are equal, then this part up here would have to equal this part down here, arc BE. That's chord conjectures. I hope that helps. Have a good day.